Okay, so we're also going to learn today about the differentiation of exponential functions. And we're going to find out why is it that the derivative of e to the x is just e to the x. You might expect it to be something else, but it's not. The derivative of e to the x is just e to the x. So if we say, first of all, that f of x equals e to the x. Now, if we wanted to find the derivative of that, we can use first principles, which you've learned about just recently. So we can say that f of x plus h is e to the x plus h. Now, we can work out what f of x plus h minus f of x all divided by h is, and then we'll have a look at the limit as it tends to 0 of h. But let's work out what this bit is here first. So f of x plus h, we have this, so that's e to the x plus h minus f of x, that's just our e to the x there, all divided by h. Now, when you're working with indices, if you multiply e to the x and e to the h together, you add the powers, and then you get x plus h. Well, we can split that apart. So that's the same as saying e to the x, e to the h minus e to the x all divided by h. We've got e to the x as a common factor now. All divided by h. We can then look at what happens with the limit. So to find the derivative, we need to look at the limit as h tends to 0. So it's the limit h tends to 0 of f of x plus h minus f of x over h, which is this expression here. Now, what we can do is we can take out this term here and we can put it out the front, because whatever happens to h doesn't make any difference to this part here. So what we can do is say it's e to the x multiplied by the limit as h tends to 0 of e to the h minus 1 over h. I don't really need that bracket there anymore. Now, as h tends to 0, e to the power of 0 is just going to be 1. We get 1 take away 1. 1 take away 1 is going to be 0. Now, obviously, as h tends to 0, as that gets closer to 0, that's going to get smaller and smaller and smaller and smaller. But the numerator, if the numerator is going to become 0, then we're okay. We don't have to worry about the numerator not being 0 and the denominator being 0, because obviously we can't have that. But if this is going to become 0, the whole thing is just going to become, the numerator and the denominator are going to be identical to one another. And if you've got the numerator and the denominator identical to one another, you just get 1, which ends up with e to the x times 1, or just e to the x. So therefore, the derivative of e to the x is just e to the x. Now, there are a few examples on the next few pages that you can work through, which are going to involve taking the derivative of that. It's also going to involve a little bit of chain rule, product rule, quotient rule. So you can work through some of these examples as well.